Okay, so we've got to change that fraction into the form that they've given us. I'll write it out again to make it a little bit easier to read. X cubed plus 3x squared minus 4x minus 12 all over x cubed plus 5x squared plus 6x. Okay, now the first thing that you might notice is that we can take x out on the bottom. So I'm not going to do anything with the top yet, but I am going to bring an x out there. So that's got x into x squared plus 5x plus 6. Okay, and again I'm just going to leave the top as it is for now. Whoops. Plus 3x squared minus 4x minus 12. But I can carry on factorising the bottom because it's an x squared, so we want an x there and an x there. We want two numbers that times to give us 6 and that add to give us 5. Well, obviously it's plus 2 and plus 3. Right, so we're making progress with the denominator. However, the numerator is a bit of a problem because there doesn't appear to be anything that individually goes into all of those terms, because we haven't got an x with the 12, it's just minus 12. So we can't simply take an x out as we did on the bottom. And because it's a cubic, you know, we can't just go straight in and try and factorise it again like we did with our quadratic factor on the bottom. Now, so this is quite tricky. However, there's something which you'll learn about when you start the A-level maths program properly, and it's called the factor theorem. And it's a very quick way of enabling us to find factors of that top term. Now let me write it out again. Sorry, of that top expression. Let me write it again. X cubed plus 3x squared minus 4x minus 12. Now let's call that a function of x. If I can find a value of x that when I substitute it in to this expression I get the answer 0, then that tells me that x minus a is a factor. Now if you think about it, that makes sense, because if x minus a is a factor, then when I put in x equals a, the bracket will just go to 0. And that's what should happen, because we found that when we put our x value equal to a, the expression just comes to 0. So what you're going to have to do is try different small numbers for x or for a, and see if we can find one where the f of x goes to 0. Well, 1 is obviously not going to work, because 1 is just going to give us 1 cubed plus 3 times 1 minus 4 minus 12. That's obviously not equal to 0. However, if we try x equals 2, okay, if we try x equals 2, we're going to get 2 cubed plus 3 times 2 squared minus 4 times 2 minus 12. Now 2 cubed is 8, plus 2 to the power 2 is 2 squared, which is 4. 4 times 3 is 12, minus 8 minus 12. Yes, that equals 0. Therefore, we know that x minus 2 is a factor. Okay, so we've got one of the factors of the numerator. Now to find the others, we're going to have to do something which you might not have seen yet, but which you will do when you start the A-level maths proper program. What we're going to have to do is divide our f of x, x cubed plus 3x squared minus 4x minus 12 by x minus 2, and that should give us a complete whole expression at the top. which we might be able to factorise further. Right, now the way you do it is you say, what do I times x by to get x cubed? Well, it's just going to be x squared, and if I do that, that's going to give me x cubed minus 2x squared. I then do a subtraction. 3x squared minus 2x squared gives me 5x squared, and I bring the next term down, and I then say, what do I times x by to get 5x squared? Well, I've got to times it by 5x. Okay, now if I times 5x by x minus 2, I get 5x squared minus 10x. And then I do minus 4x minus 10x, which comes to 6x, and I bring my minus 12 down. Now what do I times x by to get 6x? I've got to times it by plus 6. And if I do that, if I do 6 times x minus 2, I get 6x minus 12, and we get no remainder. So what that means is we have now shown that our expression on the top, our numerator, is actually this thing here, which is our numerator, we've actually shown that that's equal to x minus 2 times x squared plus 5x plus 6. Okay, however, x squared plus 5x plus 6 I can factorise, because I just get two x's. Two numbers that times to give us 6 and that add to give us 5 is obviously plus 2 and plus 3. Right, so I've factorised the numerator of our fraction. Notice that I could have done that, I suppose, by using the factor theorem again, and just plugged in the numbers minus 2 and minus 3 into my expression, and I should have got 0 for both of them. So that would have been another way to do it. But to finish now, we've got as far as this this expression here. Okay, we've got as far as that. So I'll finish it off here. So okay, right, so but we now know that x cubed plus 3x squared minus 4x minus 12 is the same as whoops, x minus 2, x plus 2, and x plus 3. But we've already got on the bottom, we've got x lots of x plus 2 and x plus 3. So you'll notice that our x plus 3 on the top and bottom cancel out, our x plus 2 on the top and the bottom cancel out, so that leaves us with x minus 2 over x. But x minus 2 over x is the same as x over x minus 2 over x. Right, and that's going to come to 1 minus 2 over x. And that's the final answer, 1 minus 2 over x.